Well, that's enough of that. So, as I said, we're being asked to integrate by recognition. We have been given this function here, and it'll say derive, hence determine the integration of x squared over 2x cubed minus 1 dx. So this, we can't integrate that on our own, and one of the tricks that I've seen a lot when I was going through the EP is a lot of people try to integrate that straight away. Because we've learned how to integrate, we want to show off our new skill. We can't do it because this is too complex and we haven't got a product rule or a chain rule or a quotient rule. So we have to use integration by recognition, which is where we derive this process first. I'm just going to call this y equals, I'm going to sneeze in 2 seconds. Yep. Here we go. Superhero. Look at that. A. Oh, recovered. 2x minus 3. I'm going to label the inside of this fx. So fx equals 2x cubed minus 1. F dash x equals 6x squared. Sweet. And the reason I did that is because I know the shortcut for these is equal to f dash x over fx, which is 6x squared over 2x cubed minus 1. Sweet. So that's the derivative, and I asked myself, why do I do that? What's the reason I did all that?
So you find the relationship.
Because now I know, due to the fact that these integration and derivative are opposite operations, correct?
Mm-hmm.
So I know that if I integrated this thing, if I integrate (6x squared over 2x cubed minus 1 dx is equal to, can you please write down what you think that's equal to? John, what is that equal to?
What equal to?
6x squared minus 6x squared divided by 2x cubed minus 1.
As in the integration?
Yeah, what's that integration equal?
Ln 2x cubed take 1 minus x.
Does it? Who agrees with Jean?
It's a close,
He's close, not really. It equals what we started with. Because I'm just saying, well, I know that if the derivative of this, sorry, if the derivative of this is this, well, the integration of this must take us back to there, correct? So I know that the integration of that is equal to ln 2x cubed minus 1. Sweet. I also know that the integration of 6x squared over 2x cubed minus 1 dx is equal to something times the integration of the thing that they asked us to do all along, x squared over 2x cubed minus 1. And what is that something? 6.
Close.
Correct?
Yes.
And I can put that at the front, it doesn't really matter. Is everyone happy with what I just did? Is anyone not happy with anything other than the temperature of the room? And now, all I'm going to do is drop this bad boy in there. So I'm going to replace that with this, because they're the same thing, aren't they? So I know that ln 2x cubed minus 1 is equal to 6 times the integration of x cubed 2x cubed, yeah, x squared, 2x cubed minus 1. And the whole time, what was I trying to get? Integration of x. I want this thing the whole time, correct? So if I want something, what do I need to do? Get it by itself, rearrange it. So how do I get rid of that 6 times? I divide everything by 6. going to get x squared over 2x cubed minus 1 ln 2x cubed minus 1 over 6 plus, you're going to see over 6 and you can call it something else, I don't care.
I should have thought it was any plus easy.
Yeah, well, I like it. I'm not that worried about that part of it. But cool? Does that make sense? So the process is derive, show that the integration of the thing that you just derived takes you back. Identify a relationship between the function you derived and the original function here. That relationship will always be constant multiplied, or in this context anyway, constant multiplied by your function and then isolate to get it by itself. Cool? I'll let you have a crack at the second one. See how we go.
I do it different as I go.